All right, so we're just going to talk about a couple of things here. I'm also going to make sure that I have the slides up just so that we can kind of go through and be on the same page here. Oops. With our notes and all that fun stuff, because we're going to finish that up right here. We'll go much quicker this time around. States of matter. So you have all of this information there. So solids, in terms of what we got going on, are states of matter. So we talked about matter itself and at least the forms that it can be, the types of matter, element, compound, mixture. But matter can be in different states. So solids, there's a fixed shape, means it can't be moved or changed very easily. Fixed volume, it takes up the space that it takes up, right? A desk is a solid. It has a fixed shape. It takes up a fixed amount of space, and that's pretty much it. The lowest energy, all right? These particles don't move much, all right? And we're talking kinetic energy, all right? KE, all right? Shout out physics. And then it has the highest, for the most part, generally, highest density, because those are so packed. All right, so the particle picture could look something like this, where you have particles that are very, very, very close together in some form or fashion, in some type of structured shape, right? So on and so forth. So when we talk particle pictures, you can just do something that's very subtle there. You can put like little wiggles around, knowing that they do move. They aren't just completely inert, but they don't like move past each other. Examples: ice, remote, right, desk, so on and so forth. You can kind of fill in those types of examples yourselves. Variable shape for liquids. All right, now we're starting to get a little bit more movement in those particles, which creates a different state of matter. They still have a fixed volume. I like to say, right, if I have a gallon of milk, inside the gallon it looks one way, and then if I pour it all out on the floor, it definitely doesn't look like it did when it was inside the gallon itself. Medium energy. Liquid's like kind of mid, it's like right in the middle. So they have medium energy. You could see particles slip and slide past one another. And then medium density. Examples, of course, all the liquids you can think of: water, milk, oil, so on and so forth. And so what do these look like? Well, look at that picture. You see now there's arrows. Now the arrows aren't terribly long. The longer the arrows, the faster they're moving, but they do tend to move and then be able to slip and slide past each other. I like to say, hey, what do you usually put on a slip and slide? Well, it's water. Hey, water's a liquid. They slip and slide, helps you slip and slide. They slip and slide past each other, right? So that's a particle picture of a liquid. And now gases, and of course, that's the other end, where gases have a variable shape. Now, again, that word variable means that it could change. It could change the way that it looks. But gases also have a variable volume, which means that they can actually take up the space that they're given, because they can spread out. So they're not always going to have the same fixed volume, kind of like a gallon of milk will always be 1 gallon. Gases can they spread out to fill up their containers. They have the highest amount of energy, which allows them to do that. So highest energy and lowest density. Because they're so spread out, even though they take up a lot of space, they're very small and don't have a lot of mass at all. So this is like air, propane, so on and so forth. So gases, they move much quicker and they're much further apart, and they can spread out amongst the cabin and take up a lot of space. All right, we're going to have a whole unit on gases. Gases are really fascinating. So we'll get you excited for that. Qualitative versus quantitative. This is just really nice to know as a scientist in general. Qualitative comes from the word quality. So we're talking about observations of characteristics. Characteristics. Observations of characteristics. So examples of that are like the shape of something, the texture, how it feels, the color, so on and so forth. Those are qualitative observations. We're going to do a lot of qualitative observations in labs in chemistry. Versus quantitative, and that comes from the term quantity, which now we're talking about observations using numbers or numerical data, right? Numerical data. So something like this, as an example, would be mass, volume, so on and so forth. Things that we can actually put a number to. So we can make sure we have that density, just to keep the train rolling there. So in terms of your qualitative versus quantitative, I would like for you to just figure out what each one should be. It's pretty straightforward. Again, if you don't see a number, it's qualitative. If you see a number that you can identify, it is quantitative. All right. And then where we will stop here is the periodic table itself. Now, we're going to get into a whole unit with the periodic table coming up. It's going to talk a little bit more about how these things are organized, but for now, we at least want to be able to read our periodic table. So we have a horizontal row, and so on and so forth. We have groups that are columns, and in this case, we're going to start talking a lot of vocab. So before we do that, we want to identify the parts of your periodic table. So that number at the very top is what we call the atomic number. I want you to show that it's the identity of the element, right? That is like its social security number. That's like its ID. And it's also the same as the number of protons that an atom's nucleus has. So that's the atomic number up there. This is just the element symbol. This is just the element name. And of course down here, this is what we call the average atomic mass. Now, this is not the same as mass number. All right, we're going to talk about what's different about it a little bit later on. But that's just showing that there's different versions of these things that exist in the world. Mass numbers are whole numbers of these. It's kind of like there's a lot of dogs in the world, but not all dogs are the same, right? So they all represent the same thing, but they are inherently different. Different shapes, different sizes. So there's different versions of magnesium that occur in our world. That's where that number comes from. But that's nice to be able to at least put a definition to a value that you see there. Horizontal row, so all of these going this way, rows, each row you have what we call a period, all right? Periodic table, period. So a period, and we're going to be using these terms a lot. A period is a horizontal row. There are a total of 7 periods, 7 rows. And a group is what we call these columns, right? So as we go through, you have these up on your periodic table as well. A group is a vertical column. There are 18 groups. So we're just going to do a very quick scavenger hunt. Then all of this is going to be just a vocab recap in terms of what those terms are and what they represent. What's the chemical symbol for potassium? So I go and I look for potassium. Oh, chemical symbol for potassium is K. Now, why is it K? It starts with a P. Because all of these, most of them, are based off of their Latin names. So something like, let's say, iron, right? You're like, iron, Fe. What's the connection there? They have this, what they call iron is actually ferric or ferrous in Latin. So a lot of these elements were not made in America, so to speak. They were found in many of the European countries. What element is represented by symbol V? I look for V up in the periodic table. Vanadium. All right, vanadium. There's V, vanadium. What is the atomic number of lithium? I find lithium, all right? And now we're just getting used to being able to identify different things in relation to what we can see and what information we're given on our periodic tables. And we're given a lot. That's pretty much your answer key to this entire semester. You just got to know how to use it. Element has the atomic number of 16. Remember, the atomic number is at the top, 16. That is sulfur. All right, sulfur. Which element has the atomic mass of 54.938? Well, can't see it on this one, so you're going to have to use your periodic tables. And your periodic table should be, I think, here. There we go. 54.93, so we keep going. And the closest one we have, that might have been a little off, 54.938, that would be manganese, MANGANESE, manganese. Fun fact, that is what makes fireworks sparkle and fall, kind of like tassel in the sky. That's a fun fact. What is the atomic mass of boron? Boron, you go to there, that is 10.81. We say AMU for atomic mass units, but more on that to come. And then what's the chemical symbol for bismuth? Something that is integral in Pepto-Bismol, if you've ever taken it. The chemical symbol is Bi. So again, from this periodic table, you are able to get a lot of information. So we're going to use that to our advantage here coming up. But other than that, that is the rest of the note sheet. All right, make sure you fill this vocab recap out. You are going to be quizzed on vocab terms and being able to know what those are. So outside of that, I hope this helps.